Hello students, today discussion is about the concentration expressions which are mole fraction, formality and normality. So to start with mole fraction. So mole fraction is another type of concentration expression but in terms of moles, only moles. Mole fraction explains about ratios between the number of moles in the solution, in a given solution. For example, if two components are there in a given solution, what is the ratio of number of moles of one component to the total number of component is called as mole fraction. Simple. What is mole fraction? It's a ratio expression in terms of number of moles. Students, answer how to find the number of moles. Like what is the formula to find the number of moles? Given mass by molecular mass is called as number of moles. Yes or no, students? So mole fraction. So let us taking the three components like A, B, C. Three components are there in the solution. Okay. How to find the number of moles of A? Look at, you can see W indicates a weight, M indicates a molecular weight. So and for A, and W2, M2 indicates a given weight and molecular weight for the component B. Similarly, W3 and M3 indicates given weight and molecular weight of the component C. Now how to find the number of moles, students? Given weight by molecular weight, given weight by molecular weight, given weight by molecular weight. Yes or no? That's how we can find the number of moles. So mole fraction equal to number of moles of one component by total number of moles of all the components is called as mole fraction. So we take an example here with this A, B, C. So if you want to write the mole fraction expression, the formula for A, B and C, could you able to write the formula, students? Yes, we can. So what is the number of moles of A? W1 by M1 divided by the number of moles expression for all A, B, C. Look at here. There's a mole fraction of A is indicate equal to X. Mole fraction is indicated by chi, a Greek letter chi, but it almost looks like X, so we follow it as X. So XA, it indicates mole fraction of A equal to, look at this expression. What is this expression? Number of moles of A divided by number of moles of A plus number of moles of B plus number of moles of C. That's how we can find mole fraction. This is one way of expressing the concentration. Yes, understood. But in terms of number of moles and mole fraction of B, what is mole fraction of B? Number of moles of B divided by number of moles of A plus B plus C. Mole fraction of C, number of moles of C divided by number of moles of A plus number of moles of B plus number of moles of C. So, but remember students, it's a ratio expression. Ultimately, if you add all these mole fractions, it should be equal to 1. Remember, all the sum of mole fractions always is a unity. It is always equal to 1. Next, so let us have one numerical here, students. A scuba tank is charged with a mixture of 1 into 10 cube mole of oxygen, which is O2, and 4.5 into 10 cube mole of helium, and determine the mole fraction of each gas in the mixture. So answer directly, number of moles are given, weights are not given, no need to find the number of moles. Then how to write the expression, students? Mole fraction of helium. So what is the formula? Number of moles of helium divided by number of moles of helium plus number of moles of oxygen. So this is the expression. 4.5 into 10 cube by 4.5 into 10 cube plus 1 into 10 cube. 10 cube will be cancelled out. So we'll get 4.5 by 5.5, which is 0.82 is the mole fraction. This is the mole fraction of helium. And what is the mole fraction of oxygen expression? Mole fraction of oxygen, like XO2 indicates mole fraction of oxygen, which is number of moles of O2 divided by number of moles of helium plus number of moles of oxygen. This is the expression with the placing the values. So 1 into 10 cube divided by 4.5 into 10 cube plus 1 into 10 cube, which is 10 cube will be cancelled out. 1 by 5.5, which is what is the mole fraction? 0.18. So now students, 0.82 plus 0.18. 0.82 is the mole fraction of helium. 0.18 is the mole fraction of oxygen. So what do we get? 0.82 plus 0.18 equal to, students, 1. That's what the sum of the mole fractions are always equal to 1. And one more thing, students, so if you feel this is a complicated expression, sir, it is taking some time, then directly if you already find the mole fraction of helium, now 1 minus this mole fraction of helium, will get the mole fraction of oxygen or not. That way also we can find the mole fraction of other component. Why? Because if the mole fraction of one component is this, what is the other component? 1 minus that. So that's how simple we can solve the mole fraction numericals. Next, formality. We already discussed about molarity in the last video, students. formality is same like molarity. Then what is the difference? The difference is simple by the definition. So in molarity, what is molarity? Number of moles in a liter of solution. Yes, sir, no, that is molarity. How to find molarity? Given mass by molecular mass, right? That is molarity, to find the number of moles. But in formality, students, it is mainly for ionic compounds, and ionic compounds molecular weight is called as formal weight. That's it. For ionic compound, molecular weight is called as formal weight. Sir, is there any change in the weight? No, there is no change. Simply the units are different, that's it. And the name is different, that's it. So if you want to write the formula, how to write the formula? Weight mass of the ionic compound by formula weight of ionic compound. Sir, what is formula weight? Same like molecular weight only. Sodium chloride. What is the molecular weight of sodium chloride? Sodium is 23. Chlorine is 35.5. What is the molecular weight? 58.5. Yes sir, no, same formula weight also 58.5 only. By the name, to specify that ionic compound, we used to call them as formula weights. Why? Because ionic compounds exist like a cluster. Yes sir, no, that's why in the crystal lattice. So into 1 by volume in liters, or if it is in ml, 1000 by volume in liters. So what is mole fraction? It is a number of formula masses in grams present per liter of solution. In case formula mass is equal to the molecular mass, formality is equal to the molarity. Like molarity and normality, the formality also depending upon the temperature. Why? Because there is a volume factor. Got the clarity, students? Same like molarity, we have the formality here, but in case of ionic compound. So we have one numerical. Let us find this numerical, students. So what is given here? 7.45 grams of KCl, potassium chloride, is dissolved in water to form 0.5 liter of solution. Calculate its formality. So formality. So students, what is the formula? Given mass by formula mass into 1 by volume in liters. Yes or no? What is the given mass? Given mass is 7.45 grams. And what is the formula mass? Means molecular mass in terms of ionic compound. KCl is an ionic compound. Potassium, what is the mass? 39. Chlorine, 35.5. So students, what is the mass here? So we have 74.4 like 5 grams. Yes or no? 74.5 grams is the formula mass of KCl into 1 by volume. What is the volume? 0.5 liters. So do we need to take 1000 here? No need to convert. Already liter is given. So students, how many times? 0.1. 1 by 0.5 is how much, students? Which is 2. So 2 into 0.1. How much, students? 0.2 formal. 0.2 formal is the answer. Got the clarity? What is the difference? Only in the case of molecular weight, you are writing only formula weight. But is the value changing? The value is not changing. So that's how we can find formality numericals also. If it in the case of molarity, what are the units? No, molarity, molar. In the case of molality, what are the units? Molal. In the case of formality, what are the units? Formal. Okay, students, got the clarity? Remaining everything all are same. By the formula also it is everything same. Right, next. Equivalent weight. So formula weight, you already have the clarity, the weight of for ionic compound. What is equivalent weight, students? Equivalent weight is, students, nothing but the mass of a substance which combines with 1 gram of hydrogen is called as equivalent weight. What is equivalent weight? The mass of a substance which combines with 1 gram of hydrogen. Sir, why do we have this equivalent weight? In the olden ways, students, in the olden days, everything to calculate, to measure everything, they used to compare with hydrogen, sir, in the very first element. That's why we got equivalent weight. So the mass, the amount of substance that combines or replaces 1 gram of hydrogen in a chemical reaction is called as equivalent weight. So for example, beryllium. So students, what is beryllium mass? Beryllium mass is how much, students? Beryllium mass is 9 grams. Yes or no? Its atomic mass. What is its equivalent weight? Beryllium combines with how many hydrogens, students? Beryllium combined with 2 hydrogens. BeH2 is the formula. Yes or no? Now 9 grams of beryllium combines with 2 grams of hydrogen. What is the definition? The amount of substance which combines with 1 gram of hydrogen. 9 grams combines with 2 grams. With 1 gram, how many grams of beryllium combined? Simple. 9 gram is combining 2 grams. With 1 gram of hydrogen, how much it is needed? 4.5 grams. That is the equivalent mass. Got the clarity? So by this definition, the amount of substance which combines with 1 gram of hydrogen is equivalent weight. But how to calculate the equivalent weight? Do all the compounds combine with hydrogen? So we have different ways to calculate the equivalent weight, students. So this is a general method to calculate the equivalent weight. In general, equivalent weight of an element equal to atomic weight by the valency factor for an element. If it's a molecule, if it's a compound, molecular weight by the valency factor. So by this formula, we can able to find the equivalent weight. So I gave an example which is beryllium hydride, BeH2, yes or no? Can we find that by this? Yes, we can find beryllium hydride. What is the valency on beryllium? Plus 2. 2 is the valency factor or not? What is its atomic mass? 9. 9 by 2, which is how much? 4.5 grams. Got the clarity? By definition it is 4.5. By the formula it is 4.5. By the valency factor also it is same. Got the clarity? Now we have some discussion about this valency factor coming. So what is this valency factor? What does it depend upon? So how to calculate for the compounds which they don't have hydrogens? So based on valency factor we can find, mainly students, we can find this valency factor based on acids, bases and salts. So acids, for acids, the number of H plus ions released by an acid is valency factor. That property is called as basicity. What is basicity? The number of H plus ions it releases. For example, HCl can release how many H plus ions? 1. So what is its valency factor? 1. Sulfuric acid can release how many H plus ions? 2. So what is its valency factor? 2. Phosphoric acid can release how many H plus ions? 3. So what is its valency factor? 3. That's it. So its mass by valency factor, and this valency factor depends upon number of H plus ions which are released by an acid. That property is called as basicity. So valency factor of HCl is 1, H2SO for sulfuric acid is 2, phosphoric acid is 3. Acetic acid contains 4 hydrogens. Do 4 hydrogens release? No, it releases only 1 hydrogen which bonds with oxygen. So what is the valency factor of acetic acid? Which is 1. Sir, why do we need equivalent weight? That I will explain the coming slide. We have one more concentration expression that is called as normality. There we use this equivalent weight. So first of all, we need to study about what is the equivalent weight and how to calculate. That's what we are doing. So here, how to calculate the equivalent weight? Molecular weight by the basicity. What is basicity? For acid, in terms of acid, we use this basicity, the valency factor only. Number of H plus ions are released. So if you want to calculate the equivalent weight of sulfuric acid. So what is the molecular weight of sulfuric acid, students? Sulfuric acid is made up of 2 hydrogens, 1 sulfur and 4 oxygens, right? 2 hydrogens, 2, sulfur 32, 2 plus 32, 34, plus 4 oxygens, 4 into 16. How much? 64. 64 plus 34. 98 grams is the molecular weight of sulfuric acid. 98 divided by, what is the basicity? 2 hydrogens it can release. What is the valency factor? 2. 98 by 2, which is how much, students? 49. So sulfuric acid molecular weight is 98 grams, but its equivalent weight is how much, students? 49 grams. Got the difference? How to find the equivalent weight? Molecular weight divided by the valency factor. Sir, where this valency factor is coming from? It is coming from the number of H plus ions are released by an acid. If an acid releases 3 H plus ions, that means what is the valency factor? 3. Its molecular weight by 3. Got the clarity? Next. We can also define in terms of bases. Acids release H plus ions, but what do bases release? Bases release OH minus ions. For acid, we are calling it as a basicity. For bases, we have to call it like opposite, acidity. Like you can see, acidity of bases. So sodium hydroxide, what is the formula? NaOH. It can release how many OH minus ions? Only 1. Yes or no? So what is the valence factor? 1. Magnesium hydroxide, MgOH taken twice. It can release how many OH minus ions? 2. So what is the valence factor? 2. Aluminum hydroxide, AlOH taken thrice. It can release how many OH minus ions? How many hydroxyl ions? 3. So what is its valency factor? 3. Got the clarity? So now see, look at here all. Sodium hydroxide 1, barium hydroxide 2, aluminum hydroxide 3. So what is once again, what is the equivalent weight formula? Molecular weight by the valency factor. What is this valency factor coming from? Basicity of acids or acidity of bases? Don't confuse. Number of H plus ions released by acids or number of OH minus ions released by a base. Very simple. So equivalent weight of aluminum hydroxide, AlOH taken thrice. And what is the molecular weight of aluminum hydroxide? It is 78. Is it equivalent weight also 78? No. Aluminum hydroxide can release 3 OH minus ions. So 78 by 3, which is 26. 26 is the equivalent weight. 78 is the molecular weight. Got the clarity? For example, if it is not an acid, it is not a base. If it is a salt solution, if it is a salt, then how to find the equivalent weight? How to find the valency factor first of all? So simple. Valency factor, the same. Beryllium hydride, what we did? We took the valency of beryllium or same. That's what. You have to take the total charge on cation or anion, not both. You have to take the total charge on cation or anion. Sodium chloride. What is the total charge on sodium? +1. That's it. 1 is the valency factor. Or if you want to, sir, I want to take anion. Chloride. What is the total charge? -1. 1 is the valency factor. That's it. Magnesium chloride. What is the charge on magnesium? +2. Yes or no? And chlorine. So how many, sir? Chlorine is -1. Is the valency factor is 1? No. How many chlorines are there? How many chlorides are there? There are 2 chlorides are there. Yes or no? 1, -1 and -1. What is the total? That is what the total charge meaning. You have to take for both chlorines. So that means 2 are not. Aluminium chloride. What is the total charge on aluminium? +3. And 3 chlorines are there. What is the total charge on anions? -3. So 3 is the value. Got the clarity? That is how we can find the valency factor. So some of the examples are given. NaCl is 1 valency factor. Potassium sulfate, K2SO4. So look at here. Potassium, what is the charge? +1. What is the valency factor? Is it 1? No. How many potassiums are there? 2 are there. That's the total charge you have to take. +1 in one potassium, +1 in another potassium. That means total how much? 2. So valence factor is 2. And aluminium sulfate, Al2SO4 taken thrice. How many aluminiums are there? 2 are there. Each aluminium how much? +3, +3. Total what is the charge? 6. +6 is the charge. Now what is the valency factor? 6 is the valency factor. Sulfate, 3 sulfates are there. On each sulfate -2, -2, -2. Total what is the charge? -6 or not? Valency factor is 6 or not? Got the clarity? Once again I am repeating, students. Equivalent weight you can find from the molecular weight by the valency factor. This valency factor depends upon number of H+ ions released by an acid, number of OH- ions released by a base, or the total charge on a cation or or anion. That is the valency factor. Here equivalent weight of sodium chloride. What is the molecular weight of sodium chloride, students? Sodium is 23, chlorine is 35.5, which is 58.5. And what is the charge on sodium or chlorine? 1. So what is the valency factor? 1. So what is, find the equivalent weight? 58.5 by 1. How much? 58.5. If the valency factor is 1, molecular weight is equal to equivalent weight. Got the clarity, students? How to find the equivalent weight? So sir, why do we need to find the equivalent weight? The reason is, students, how to find the number of moles? Molecular mass by given mass by molecular mass. Yes or no? How to find the number of moles? Given mass by molecular mass. You know, here instead of molecular mass, if you have taken equivalent mass, we'll get one more entity that is called as number of gram equivalents or number of equivalents. It's same like number of moles, but it is not number of moles. It is called as number of equivalents. How do we get? Given mass by equivalent weight or equivalent mass. How to find number of moles? Given mass by molecular mass is number of moles. Given mass by equivalent weight is number of gram equivalent. Got the clarity, students? We have the one numerical here, which is calculate the number of equivalents present in 20 grams of sodium hydroxide. What is sodium hydroxide, students? Sodium hydroxide is NaOH. Okay, this is sodium hydroxide. How to find what is the molecular mass of sodium hydroxide? Molecular mass is sodium 23 plus 16 plus 1. How much? 40 grams. Yes or no? And how to find the equivalent weight? How to find equivalent weight? Molecular weight by N factor. Valency factor. N means valency factor. What is molecular weight? 40. Clear? What is N factor? Means like valency factor. This is a base. It can release how many? OH- ions? Only 1. Or if you want to answer in terms of charge, what is the total charge on sodium? 1. So valency factor is 1. That means what is the equivalent weight? 40 grams. Yes or no? And they are not asking equivalent weight. They are asking number of gram equivalents. Look at the previous slide. Look at the previous slide. How to find the gram equivalents? Given weight by equivalent weight. So given weight is how much? 20 grams. So that means 20 by, what is the equivalent weight, students? We already have found 40. So now how much is the number of equivalents? 0.5. 0.5 is the number of gram equivalents. 1 by 2. Got the clarity, students? So number of moles is given weight by molecular weight. Gram equivalent weight is given mass by gram equivalent mass. How to find the gram equivalent mass? Molecular weight by the N factor. This is what we already discussed in the previous slides. So next, normality. For this concentration expression, till now all the discussion is about. So normality is it is defined as normality also same like molarity, but there is a change. Definitely there is a change. What is the change here? The change is molarity is number of moles present in a liter of solution. In 1 liter of solution is molarity. What is normality? Number of gram equivalents present in a liter of a solution. That is the difference. In terms of molarity is in terms of number of moles, normality is in terms of gram equivalents. Sir, how to find the gram equivalents? This is the formula. Weight by equivalent weight. Sir, how to find the equivalent weight? This is the formula. Understood? Got the clarity, students? Right. So, the formula is same. Number of gram equivalents of a solid by the volume of solution in liters. If you want to convert in ml, 1000 by volume in ml. Weight of the substance by gram equivalent weight. So, we have one numerical here to find the normality. So, what is the normality of 1 liter? Volume is 1 liter when 18.5 grams of calcium hydroxide is dissolved in water. So, first what we need to find, students? We need to find equivalent weight. Yes or no? How to find the equivalent weight, students? How to find equivalent weight? Molecular weight by N factor. What is the molecular weight? Calcium hydroxide formula? Ca. Students, calcium hydroxide formula is CaOH taken twice. Okay. Now find the molecular weight of calcium hydroxide. Calcium atomic mass is 40 grams. Oxygen is 16. Hydrogen is 1. 16 plus 1, 17 into 2. 34 plus 40. How much? 74 grams is the molecular weight. And what is N factor, students? What is N factor? Calcium hydroxide. How many it can releases? It can releases 2 hydroxyl ions. Yes or no? So 74 divided by 2. That's it. Now solve this. How much? So 37. So 37 grams is the equivalent weight of. It is the equivalent weight of calcium hydroxide. What is its molecular weight? 74 grams. Its equivalent weight is 37 grams. Now this is not the answer. We have to find the normality. Now what is the normality formula? Normality equal to given weight by equivalent weight into 1 by volume in liters. What is given weight? 18.5 grams. Okay. What is equivalent weight? 37. Second, students. 37 into 1 by, what is the volume? Volume is, students, 1 liter. That's it. 1 by 1. Okay. Now 18.5 by 37. How much, students? 18 2s are 36.5. 37, right? So 2 times 1 by 2. 1 by 2 means, students, 0.5 normal capital N. That's it. That is the normality of calcium hydroxide, which is present in 1 liter for 18.5 grams. So what is the unit? Normal, capital N. For molarity, molar. For molality, molar. For normality, normal. Got the clarity, students? So next we have the relation between normality and molarity. Listen carefully here. So molarity, what is molarity formula? Number of moles. What is number of moles? Weight by molecular weight into 1 by volume. Yes or no? If you take out this molecular mass to the left hand side, molarity into molecular mass equal to given weight by volume in liters. Yes or no? What is that given weight by volume in liters? That is the strength of the solution or not? You remember the previous video. Once check out the previous video, students. Given weight by volume in liters is strength. So molarity into molecular mass equal to strength of the solution. The same for normality expression also. Normality equal to weight by equivalent weight into 1 by volume. If you take out this equivalent weight to the left hand side, normality into equivalent mass equal to weight by volume in liters. Yes, sir. What is it? Weight by volume, which is nothing but the strength of the solution. Now we can equate molarity and normality or not. So molarity into molecular mass equal to normality into equivalent mass. Why? Because both are equal to the strength of the solution. Now just rearranging the expression, normality, that means normality by molarity equal to molecular mass by equivalent mass. Molecular mass by equivalent mass. So what is this expression molecular mass by equivalent mass? N factor. Yes or no? Equivalent weight equal to molecular weight by N factor or not? Now N factor equal to molecular mass by equivalent weight. So the whole expression becomes N and normality equal to N into molarity. This is the complete relation between normality and molarity, students. This is a complete relation between molarity and normality. So with this expression we can able to find the relation between molarity and normality also. Equivalent mass equal to molecular mass by n. This valence factor is nothing but indicated by n factor. So next we have here, calculate the normality of 1 molar H3 PO4 solution, phosphoric acid solution. So what is the formula? Normality equal to n into molarity. What is n factor for phosphoric acid? You can say, what is n factor? How many H plus ions it can release? 3 H plus ions it can release, correct? So n factor is 3. And how much is the molar? 1 molar. So 3 into 1. So what is the normality? 3 normal. That's it. Because here normality, why? Because here molarity is 1, right? But the valency factor is 3. So that's why normality is 3. If molarity is 1, for valency factor 3. What the clarity, students, between this relation? Next, dilution law of normality. Same like molarity, dilution law means we have initial molarity, final molarity. Same like we have, if we change the volume, we have initial normality and final normal. So V1 N1 equal to V2 N2 is the formula for change. If you know any 3, you can find the fourth one. So we have one numerical here, students. So 0.5 molar H2SO4 is diluted from 1 liter to 10 liters. Calculate the final normality. What is given here, students? What is given? Molarity is given, they are asking final normality. How to convert, what is the relation between molarity and normality? Normality equal to n into molarity. Yes or no? What is the n factor? N factor is 2. 1 second. What is n factor? N factor is 2. 2 into, what is the molarity, students? 0.5. Yes or no? 2 into 0.5, how much, students? 1. So 1 normal. Got the clarity? We got the normality. So what is the relation? V1 N1 equal to V2 N2. V1 N1 equal to V2 N2. What is V1? Initial volume how much? 1 liter into, what is initial normal? 1 equal to, what is the final? Final is 10 liters, right? 10 into, what is the final? That's what we need to find, N2. So N2 equal to 1 by 10, which is nothing but 0.1 normal. This is the final normality. Got the clarity, students? So that's how we can, even if molarity is given also, we can find the normality based on this relation. So that's all, students. That's all for in this video. What we discussed in this video, mole fraction, which gives the relation between, in terms of moles, the ratios, and formality, same like molarity, but in terms of ionic compounds, only formula weight. Next, normality is in terms of gram equivalents, not number of moles, gram equivalent. How to find the gram equivalents? Same, given mass by equivalent weight. How to find the equivalent weight? Molecular weight by the n factor. How to find the n factor? Like all we discussed. Number of H plus ions released by an acid, OH minus ions released by a base, or the total charge on a cation or an anion. That's it. In this video, students, about all these concentration expressions are completed. I hope you got the clarity, and thank you.